Hey guys, welcome to lesson 9 of how to make iPhone apps with no programming experience. In the last lesson, we built our user interface in the storyboard and we learned all about auto layout. Before we expose those elements to code, I wanted to go through the basic building blocks of the Swift programming language so that when we do look at code, you can understand what's going on and what the various lines of code mean. So in this lesson, we're going to go over some concepts that may be difficult for you to understand if this is the first time you've ever seen or heard about them. We're going to go through classes and objects, we're going to go through methods, and we're going to go through properties. Okay, so let's jump right in. The first concept is a class. A class is a blueprint that we can create to describe a component of our app. When we're making an app in Xcode, really all we're doing is creating classes to describe the various components in our app and how they interact with each other. For example, in that MVC diagram I showed you before describing the various components of an app, the behavior of the model will be described by a class, the view controller is described by a class, and the view as well. In each of those classes, we write code to give it instructions on what to do and how to act. So in the view controller class, I might write some code to tell it to ask the model for the data and then display it to the view. And then in the model class, I might write code to say, if the view controller asks you for data, then go fetch the data and then return it. Are you with me so far? So a class contains instructions written in code to describe how a component is supposed to act and how it's supposed to interact with the other components. Another thing to realize is that it's not the classes themselves that are doing the interacting. The classes are merely blueprints that we're creating. What happens is that these blueprints, also known as classes, are turned into what's called objects. So from the model class, a model object is created. From the view controller class, a view controller object is created. And from the view class, a view object is created. And it's these objects that interact with each other and carry out the functions of our app. Furthermore, from one class or one blueprint, you can create multiple objects in the same likeness and behavior that the class describes. And this makes sense because imagine, if you had two components in your app that did the same thing but in two different places, you can code up one class and create two objects from it. Another example would be, say, in a game where you spawn multiple enemies of the same type. You shouldn't need to create a class for each enemy that appears on the screen. You only need to create a single class that describes the enemy's behavior, and then use that class to create multiple enemy objects to throw at the player. So the key takeaway at this point is that the components in our app are described by classes. Classes are like blueprints that are used to produce objects that act and behave as described in the class. And it's these objects that interact with each other to perform the duties of our app. Now let's try creating some classes in a playground. And in lesson 2, we learned how to start and create a new playground from Xcode. Open up a new playground and we're going to type out some code. So to create a class, simply use the class keyword and then give your class a name. So for example, I'm going to call my class person. And then all you're going to do is open up a set of curly braces. Inside the curly braces, you're going to type init and then two round braces like that, and then another set of curly braces. So when I type out this left side curly brace and I just hit enter, Xcode will automatically fill in the second one. So that's just a little shortcut. And then just like that, you've created a new class to describe a component of your app. So what is this init here? Well, any code that you put in between these curly braces right here, so any code that you put in the middle here, gets executed when a new object of this class gets created. So when a new person object is created, the code inside the init is run, and that code can be used to set up or initialize anything that you need for the person object to function properly. So let's try that. Let's create a new object of our new person class. So you can do that very simply just by typing the class name followed by 2 round braces like that. And just like that, we've created a new object. However, what we want to do is create a variable just so that we can reference our object later. So I'm going to create a new variable. I'll just name it A. So now I've created a new person object and I've assigned it to the variable A. So now when I want to reference that object, I can use the variable A and I can do stuff to it, as we'll see soon. So I'm just going to erase that line. And let's put a print line statement in the init, just so we can see that it gets called when we create a new object. So let's say new person initialized. Okay, so now when I create a new person, you can see that the print line statement is run, and you can see that that's the output. Okay, so this is great. We've created a new class to describe a component in our app, but we need to give it instructions to do something, to describe its behavior. And how do we do that? We do that through something called methods and properties. Those are 2 different things, and we're going to go through them individually. So let's talk about methods first. A method is a named set of instructions that will be executed when called. Additionally, methods can accept some data as input and return some data as output back to the caller of the method. And finally, methods are associated with a class. So let's try to create a method for our new person class. So what I'm going to do is just create some space here right below the closing curly brace of our class. And in order to create a method, you start with the func keyword, stands for function, and you give your method a name. So I'm going to call it say cheese. So that's my method name. And then you want to give it a set of round braces followed by a set of curly braces. And inside this set of curly braces, you write the code to execute when this method is called. So inside my say cheese method, I'm going to just at this point here print line cheese. Okay, so as you can see, going back to it, when we create a new object right here, cheese doesn't get printed out because this line of code only gets executed if this method is called, and it's not being called right now, right? So what I can do in order to call the method is just type, since I've got a new person object assigned to my variable b, I type in b dot say cheese with the brackets. When I do that, you can see that this line is printed out. So when I write this code statement, it actually runs this code in here. Okay, let's look at this method call. What is b.sayCheese? Well, method calls take the format of the object that you want to call the method on, dot method name. So that's why, because my person object is in the variable b, when I write b, that refers to that object, and I write dot to look at all of its properties and methods. At this point, it's only got the sayCheese method, and then you write the method name to call this object's sayCheese method. Okay, so let's say we don't do that. Let's try to call that method as part of the initializer. And you might notice at this point that this initializer kind of looks like a method, except that it doesn't have this func keyword. Well, you're right. The initializer is basically a method, but it's a special type of method because all classes need to have an initializer. So anyways, I'm going to erase this print line here, and instead I'm going to call the sayCheese method from in here, so that whenever we create a new person object, this initializer method is run, and inside this initializer method, it's going to call its own sayCheese method. So the way I do that is I write self dot say cheese. As you can see, when I create this new person object, cheese is printed out, even though I didn't call the method explicitly here, because the initializer method calls the sayCheese method. Now you might be wondering, what does self mean? Well, self means call a method that you own yourself. So to help you understand the self keyword, take a look at this slide. Imagine that we're writing a set of instructions for the created object to read itself. So each object is created in the likeness of the class, and when they read that line of code, they're like saying to themselves, call my own method sayCheese. So if you think about it that way, it may be more intuitive to understand why the keyword is named self. Okay, next we're ready to look at properties. A property is something that we can create for a class in order to allow it to store a value or keep track of another object. Let's go back to our playground and see how to declare a property for our class. So I'm going to find a space here right below the opening person bracket. Properties are declared at the very top. So you start with the keyword var, followed by the property name. So I'm going to say name, followed by colon, followed by the type of data that property is going to store or track. In this case, I'm going to write string. Remember, string is just a piece of text. And next, we also have to give it an initial value. So I'm going to use the equal symbol to assign something to it. I'm going to assign a piece of text into this property as an initial value. I'm just going to give it a piece of string that says initial name. And just like that, we've declared a property for our person class and gave it an initial value with this piece of text. Now you may notice that a property declaration sort of looks like a variable declaration. If you remember in lesson 2 when we did something like, let me just erase this line for a second. When we did something like this, where we created 3 variables with the third one being the sum of the first 2, well, this almost looks like a property declaration. You have the var keyword and you have a name for your variable. And you know what? You're right, because even with a variable declaration, we can put that colon there and then put the type of data that variable is going to hold. And for numbers, we use int. It stands for integer. So we could have done this, and now it looks even more like a property declaration. In fact, it's actually a good practice if you know what data that variable is going to be tracking, that you want to specify the type of data so you don't accidentally use that variable later expecting a number, but maybe you accidentally put another type in there, and then you may create a bug that you don't even know about. By specifying the type that you expect to be in there, if you try to put another type of data in that variable, it will complain and it won't let you. Okay, so then what are the difference between variables and properties? Well, it depends where it's declared. When it's declared here inside the person class at the top, it becomes a property of that class and it's associated with the class, while variables are declared and used within methods. Okay, now let's look at how to access a property. So I'm going to erase this. Now I'm going to declare a new variable. Now I just realized that I just said that variables are declared within within methods, and they normally are, but because this is a playground where kind of it's just a place to test code, that rule is kind of out the window here. But you'll notice when we write code inside Xcode, we will be following those rules, where most of the variables that we declare will be inside methods, and anything that we declare outside are properties. So I'm going to create a variable called first person, and I'm going to create a new person object. So in order to access that property, it follows the same format as a method call. I reference the object that I want to call its property on. I hit dot, and then now I can either write say cheese to call its method, or write the property name to call its property. And you can see there it's accessed initial name. Now if I want to change the property, I can just go like that, and I can assign it a different piece of text. Now if I access that property again, you can see that it's changed and now it says Alice. I'm going to create a second person. Well, I'm going to create a second variable and create a new person object inside and assign it to that second variable. And I'm going to change its name property. Okay, so take a look at this. I've created another person object, assigned it to the variable second person, and I just changed its name to Bob. Well, what would you expect first person, their name to be? Let's find out. Well, the first person's name is still Alice, and that illustrates a very important point. Although each object is created in the likeness of the class, they're actually independent instances of each other. Remember, you can use one class to create multiple objects of that class, but each of them are independent instances. So what you do to one object does not automatically apply to all of the other objects. They're independent. Okay, so that's where we're going to end off this lesson. This was just an introduction to classes, methods, and properties. There's actually more complicated things that you can do with them, but we'll look at that when we need to. If this was your first time learning about classes and objects, then welcome to the world of object-oriented programming languages. You'll probably need to watch this video again, or maybe even a couple of times to wrap your head around it. Swift, along with many other programming languages, are object-oriented, so in the future, when you've mastered Swift and you decide to learn Java for Android apps, C# for Windows Phone apps, or perhaps even Objective-C, you'll have a head start because they use the same concepts that have been presented in this lesson today. And on a closing note, if you've watched this video a couple of times and you're still a bit confused, don't worry too much about it because we're going to be putting this stuff into practice and it's going to click when we do. In the next lesson, we're going to go over a couple of more Swift programming language concepts before we actually dive into the code in our card game app.